Hi, I'm here to tell you about the process we use to collect macroinvertebrate or bug samples from wadeable streams in Washington State. If you want more information on this process, you can go to our website at tinyurl.com/watershedhealth. So the procedures we're going to talk about today are used by the Status and Trends Monitoring for Watershed Health program and also by the Freshwater Ambient Biological Monitoring program. The data we collect will be used to measure biological integrity as well as ecological quality of a stream. Now there's a lot of reasons to use insects as a biological indicator. Aside from the fact that they're pretty easy to collect, they're not very migratory. They don't move in from distant locations. Generally, an aquatic insect spends most of its life, at least the phase that it is aquatic, in the same location. And what this means is that the communities you collect from any given site actually represent the conditions in that stream at that site. This is a pretty straightforward process. It can be completed by a single crew member, and it's generally one of the first tasks that are completed when you arrive at a site. Before you can collect your samples, though, you need to establish your reach. Our programs work on a reach-wide basis. We collect a lot of different habitat and stream information on a reach-wide basis. So a reach is generally defined as 20 times the bank full width, although a reach is never shorter than 150 meters and never longer than 2 kilometers. Once you establish your reach, define how long the reach is going to be, the assessment crew will establish 11 equally distant transects across the reach, and these transects will be perpendicular to the flow of the stream. When you collect your macroinvertebrate data, you're going to randomly select 8 of those transects to pull samples from. So when you get to your first transect to collect data, you want to figure out where on that transect you're going to collect from. The first transect you're going to move in 25% of the way from either the left or right bank. The next transect you'll move to 50% of the way across. The following transect to 75. On the fourth transect you'll move back to 50, and so on, zigzagging your way back and forth across the stream until you've collected all 8 samples. It's pretty straightforward equipment also required for this process. There's very little equipment that you actually need. Our primary piece of equipment is the D-frame kick net. D-frame kick nets should be approximately 1 foot across at the bottom of the net and about 1 foot in diameter. In addition, you should have a 500 micron mesh attached to this kick net. This is a pretty standard mesh size. It's used by a lot of different agencies, both state and federal. And the standardization of that mesh size helps to make your data comparable not only within your program, but with other agencies. In addition to this kick net, you also need a wide mouth jar. So one of the reasons that we use wide mouth jars is because it's easier to get your hand into and get your sample in there. If you have a narrow mouth jar, it's really hard to get everything in there. Also, you're going to need some labels. You're going to have one label to go on the outside of the jar on the face, and you're going to have another label that you're going to fold up and stick inside your sample in case this label gets destroyed. So I'd recommend printing your samples out on waterproof paper so that neither one of them get destroyed, hopefully. Of course, you'll need tape to affix those labels to the outside of your jar. You need a pencil to fill the labels in, and you need some weighting gear. Now, I mentioned earlier that we collect our samples on a reach-wide basis. The fact that we collect on a reach-wide basis and that we predetermine which transects we're going to collect that data from means that you're going to encounter both fast-moving water and slack water conditions. So flowing water conditions are any time that you're in a stream and the flow of the stream itself can carry the organisms into your net. A slack water condition then is one where the water is so still that you actually have to move the net through the water to get your bugs in. We're going to demonstrate both of those today. In the interest of equal sampling effort, we collect 8 square feet of surface area at each reach that we visit. What this means is that at each of the 8 randomly selected transects, we collect insects from 1 square foot of surface area across the stream bottom directly in front of our net. Now some people like to use frames. They attach a frame to the bottom of the net and that'll help guide their sampling area. Sometimes that gets a little difficult if your bottom surface is really uneven or if you're in like a really cobbly or bouldery sample site. Another thing that you can do just to give yourself an idea of approximately where you're going to sample is you can make yourself some kind of a little frame or use a ruler, and you're going to place it down on the stream bottom where you can see it. So once you've got the idea of how much room you're going to sample from, how much space you'll sample from, you're going to want to first of all remove the larger objects out of your way. And there's really 2 different types of insects that you'll find in the creek. You find those that cling to rocks and those that live in the interstitial spaces of the rocks and sediment. And so what you want to do is you want to take all the cobble-sized substrate out from in front of your net. You can use your hands or you can use a brush. A brush will help you get into the crevices a little better, and there's a lot of little critters that like to hide in there. They get, there's several that make different types of cement. You can see these guys have really cemented themselves on, and so you just want to make sure that you get all those guys washed off and into your sample net. Make sure that you're brushing them off in the flow of water so that they go right into the net. When you're done cleaning a piece of substrate, you just set it off to the side. So you may have an event where you get a really large rock embedded in the dirt or the substrate of the stream, and it may be too large to lift. What you want to do in that case is you want to get your brush down there, your hand, and just scrub across the surface of it. Make sure you get as much of that flowing into your net as possible. And then you're ready to start the kick. So again, you want to visualize that square foot of surface area directly in front of the net. And you're going to start from the back of that square foot, just picking and lifting up the sediment. You see all the iron and the sediment flowing into the net here. And what you want to do, the purpose of this is to lift the sediment and the insects that live in there into the water column so that the water can brush those into your net. You want to try and get down in about 4 to 5 centimeters deep, and you're going to kick for about 30 seconds. You're going to time that on your watch or your stopwatch. Okay, so 30 seconds is up, and I'm going to pull this up. And this is what you come out. This is your sample when you first get it out of the creek. And you can see that there's a lot of stuff attached to the sides. You have little chironomids like this one stuck here on the side, so you want to make sure that you wash everything down the net. Get it down into the bottom of the net. It makes it easier to pull out of the net when you get to your sample jar. So you can let the stream help you out with this. Alright, so you're just going to let the flow of the water take it on down. And you can see, even after all that, you have a lot of these insects that cling to your side of your net. Alright, so we've got pretty much everything washed down to the bottom, and you can see that you have a few larger pieces. So now we've got our sample in our jar. We have the outer label affixed to the outside. We've placed the inner label inside the sample just in case something happens to the outer label. And we use 95% non-denatured ethanol as our preservative. So you're going to mix 3 parts preservative with 1 part sample. We've just collected our first sample out of 8, so you're going to continue up to transect, and you're going to put all the rest of your samples into the same jar. So your ethanol will be mixed in at the end of your work. Alright, so this is our first slack water transect that we've come across, and you can tell that not much is happening here. We're going to have to sweep the net through the water in order for the insects to be captured into our sample. So from what I can feel underneath my feet, this is mostly organics and fine sediments. If you were in a rockier situation, you would want to try and get down there, grab those larger rocks and brush them off like we did in the fast-moving water section. But we've got fines and organics. So you're going to again visualize a square foot of area in front of you. I'm facing upstream just for standardization's sake. You're going to identify your square foot area in front of you, and you're going to again begin to kick. You're going to kick the sediments up, and then you're going to sweep your net through the cloud of sediment and continue kicking and sweeping for 30 seconds. Alright, and 30 seconds is up. You can see that this sample is a lot more organic matter than the previous sample was. And so just as we did before, you're going to take that sample and dump it into your net. You're going to wash everything down, wash the sides of the net down. Try and get everything in the bottom so you can grab hold of it. Again, you can see you're actually probably going to be more likely to collect large pieces of organic matter, so you just want to go through, make sure you clean those off. Get any of the organisms that are on them off and take them back out of the sample. And that's how you're going to get your sample out of a slack water situation.